And this is going to take a little bit of it's going to be a process for you to grasp this next concept. And please don't be frustrated if you're sitting there and you're like, I don't get it. I don't, like, your classmate is like, oh yeah, totally got it. I know exactly what to do. And you're like, I still don't see it, right? Don't give up, okay? Just keep going, keep practicing. I'll try to give you many opportunities to get to wrap your hands around it. So we were going to solve problems that involve composite shapes and even hollow shapes, okay? Now that we have reviewed and derived the formulas for the most common shapes, we can use the knowledge to determine the surface area and volume of more complex shapes. So we're going to put them together, okay? One thing that I'm going to suggest to you is I'm going to emphasize this, write down the formulas required. And also include formulas for the faces that need to be subtracted, perhaps. Okay? If you solve everything separately, do not round too soon. So we used to have the old calculators. I would tell my students use 4 decimals minimum. Now that we have these ones, I would say use all decimals as you're solving. Okay? Make sure that your answer makes sense. What do I mean by that? If it's like, hey, how much water is in this cup, and you get like 230 million? Sure, I make mistakes all the time, but it's probably not right, okay? When multiple shapes connect, okay? When shapes connect, do not include that portion. So what do I mean by that? So an example would be, if you have a cylinder, right, and it has a cone sitting on top of it, this circle right here is what I'm talking about, okay? You would not include that when you're finding the surface area of the cone, right, because it's not exposed. You would also not include it if you're dealing with the cylinder. This would have to be omitted. Okay, on both sides, from both sides, both approaches. Okay, do not include that twice. And one more note that I just thought of this morning. Okay, this is important because I'm always trying to think what went wrong in the past. Like, I'm trying to learn from students' mistakes. Okay, write this down. When shapes have holes, try to imagine, okay, can I use the OG? I snuck OG in there. The original. Try to imagine that original. Hey, that looks like it used to be a circle, right? Then subtract what is missing. Okay? Subtract what is missing. So, for example, if I said find the area of the shaded portion, okay? It's like, I don't have a formula for that. I don't know a shape that looks like that, but what's the OG here? What's the bigger one? The circle, right? What's missing? A square. Well, then start with a circle, subtract a square. Okay? That's what I'm trying to talk about. So it's basically circle minus a square. Okay, if you want to think about it that way, that's what happened there. Okay, so we'll do the first one here on page 14. If you have a few highlighters, it's probably a very good idea to have them out for this part. have it on there. There we go. A company needs to produce cardboard boxes as depicted below. Okay? Calculate the amount of cardboard needed. The hint is that's courtesy, okay? But I would expect you to know that down the road, cardboard needed would be surface area, okay? It's like what makes that shape, okay? How much material needed to construct. That's A. And then B, what would be the capacity of the box? What are you thinking if it says capacity? Volume, yeah. A hollow object has a capacity, can hold stuff. So this is volume, and this is surface area. Okay. And C, I'm just gonna omit for now. I have the complete question here, but I'm just gonna focus on surface area and volume right now, because to be honest, that's gonna be enough. Let's do the volume first. I'm going to do the volume in this space right here. Volume is easier than surface area, okay? So I'm going to call this total volume. So total volume, TV, is going to be the volume of the cylinder plus the volume of the box. It's basically a rectangular prism. Are you agreeing with me that we need to add the volumes, right? There's no hole or anything. We're not taking anything away. It's stacked, so we add. Keep that in mind, okay? So total volume. What's the volume of a cylinder? You look at your study sheet, and you're going to say, hey, it's pi r squared h. I would really like you to write out the formulas. Plus, what's the volume of the box? Length times width times height. Sometimes you're going to be creative here. Oh, there's H and H. So sometimes students put a 1 and a 2 there, and they differentiate that way. I think it's safe to say that here we're not going to mix them up, okay? But sometimes when it gets very busy, we might. So let's do this here. Pi, do we know the radius of the cylinder? Not off the top, but we can quickly find out what it is, right? The radius is 1.5. So I'm going to plug that in here, 1.5 squared. Do I know the height of the cylinder? 20. Sometimes, guys, sometimes you might think you don't know it. Look again, okay? Look at the shape. Like, is there any way that I can maybe find numbers that are alongside it to figure it out? Plus, now we're talking about the box here. The box is length times width times height. Okay, and then we just calculate that. So volume is usually pretty straightforward if you know the formula. So I'm just going to go pi times 1.5 squared, press the x2 button for that, times 20. So that'd be 141,371, and I keep going, plus the other side, 10 times 6, right? 4 times 6 is 24, times 10 is 240. And so basically I just need to add, you can just go plus 240, it will take your previous answer and add 240 to it, and here it is. Total volume is 381.37 squared inches. No, cube inches. So circle your final answer, be clear about it. This is the volume of this. So this is basically answering, I answered B here, right? So this is part B, I did that first. And now we're going to do the surface area, which is a bit more tricky. It's a bit trickier for sure. So let me try here. I would like the shape to stay on as I solve. I can do this, I can do this. There we go. So, yeah, go ahead. So let's do the surface area. I call this TSA. And I'm going to tell you this. If you're careful, you can do it your way, and it may look very different than mine, but you just have to be careful and show me how you do it. Okay, guys? So how I'm going to approach this, I'm going to do surface area of the box, surface area of the box, plus surface area of the cylinder You're like, wait a minute, you're just adding, Mr. Dirksen, you're not going to take anything away? I will in a bit. So you're partway there if you're saying, yeah, surface area of the box, surface area of the cylinder, but what needs to be taken away? Look at the box first. This needs to be taken away, right? Because that's not exposed. Okay, so we got to go minus area of a circle. Okay, is there anything else we need to take away? So we did surface area of the box, we subtract a whole circle from it. That way, if I look at the box, I'm not including that circle there. That's good. But when I look from the top, like when I look at the cylinder, what do I need to take away from the cylinder? I need to make sure I don't include both circles. Because if you do 2 pi r squared plus 2 pi r h, you're going to include this from the perspective of this cylinder, and you don't want that. Okay? So I'm going to go minus area of a circle again. If you do that, you will in fact make sure you don't account for this twice. Okay? We're good? Okay, so let's do this. Total surface area. Surface area of the box would be 2 times, do we want to write out the formula? I think we can just plug in. 2 times length times width. 2 times length times height. Plus 2 times 10 times 6, that's width and length. 10 and 4, and then it's 6 and 4. So you should have 2 brackets that include the height of this thing. Okay. Minus area of a circle. Oh, why do I do this? Minus pi r squared. Sorry. Don't do the minus yet, let's do the cylinder. Plus 2 pi r squared plus 2 pi rh minus, can we just combine these two to 2 pi r squared? Okay, these are 2 pi r squared. Because I'll make sure you understand, this is pi r squared, and this is also pi r squared. So we're just taking away circles. So these two combine, right? When I combine these two, I ended up with just 2 pi r squared subtracting at the end. Okay. So I told my audience what is it that I'm going to do. I wrote out everything out. I still need to clean this up here. So let's figure out what this is. You can actually do that all in one shot with your calculator here. Or you do mental math, it's up to you. 2 times 10 times 6 plus 2 times 10 times 4 plus 2 times 6 times 4. You get 248 for the box. Okay. So this is 248 plus, I don't know why I didn't clean this, why I didn't put the numbers in here right away. I think it is because I wanted you to see this. Do you see something that can be canceled out here? You see these two here, 2 pi r squared and minus 2 pi r squared? They can be canceled out, okay? So, sure, if you didn't see it, you would have just done more work. But really, these two can be taken away. And then you end up with 2 pi RH on that side. So that's 248 plus 2 times pi, the radius is 1.5, and the height is 20. And I will just do this number here on the side. So it's 2 times pi times 1.5 times 20. That's 188. So just add 248 to this, and you end up with 436 point, what do we round that to? 50, right? The 9 bumps the 4, because this 5 will bump that to a 10, which bumps this to a 5. So it's really 50, right? And we are in squared inches. I would actually encourage you, if you have time, cover what I just did. Okay, cover my work and say, can I do this my way and get the same answer? And if you do it right, you will. Because this can be done differently. Like I've seen students work, and sometimes it's like, huh, I never thought of this, and they got the same answer. So just show me your work. Okay. One thing I wanted to highlight. I hope you can see this. Like I wish the whole shape was on here, but maybe let's do like this circle right here. Right? It's this part right here. Right? I had to take it away from both of them. Right? And why so? Because the box includes that circle, so I have to make sure I take off that circle. The surface area of the cylinder, like that entire formula, adds both circles, so I had to take away a second circle here. Okay, so that's why I did this, and it canceled out at the end. But even if you missed it, you would have still gotten the right final answer. Okay. Anyways, I want you to try. So I'm going to skip. There's more that I want to do with you, but I can't just talk the whole time. You're going to fall asleep on me. So I'm going to ask you to try pages. I'm going to leave the crazy ones out for now. I think it's page 21. I'm just going to check real quick if yours is also 21. Yeah. So I want you to try pages 21. I'm going to say for now blanket, page 21 to 24. And I'll say this, the more you do this, the better prepared you're going to be what we're about to do down the road, okay? The more you do this, the more prepared you're going to be. And I'll take this. I'll take it like Mr. Dirksen, I tried this, a bunch of these, and I still don't get it. If I see your work and you come and ask me questions, I will be like, gladly help you. Like I actually know right away what you got wrong, okay? So pages 21 to 24, I'll give you the rest of the class, 5 minutes. Thank you, Mr. Dirksen. That's like pennies. I know. And I may even give you a little bit of time on Monday to try some that are trickier that I've made. I'll prepare you for that. Okay, one more thing I want to say here. Some of these questions are going to be a little bit overkill, like you'll see what I'm talking about down the road. But but this is the dilemma we have as teachers, especially if there's a provincial exam at the end. We don't know what they're gonna throw at you. So sometimes we do, like you're gonna write your exam, and you're gonna be like, Mr. Dirksen, that was overkill. Like, this was a pretty simple question, right? Yes, but sometimes they throw something at you that you're like, I've never even seen something remotely like this, but you will have seen a lot of different cases, and hopefully that'll prepare you, be like, oh, I got this, right? I know how to approach this. So that's what we're trying to do here. Okay,